In this video, we're going to look at using de Moivre's theorem. So just to start with, I've written out Pascal's triangle on the left because we are going to use it at some stage. If you use the formula where you use like n choose 0 or n choose 1, that's completely fine to use here as well in the expansion part of this question. Now throughout this question, I'm going to use c to represent cos and I'm going to use s to represent sine. Now any complex number is written in the form c plus is, and so here we're applying a power of 6. The reason we choose a power of 6 specifically is because we want to get cos of 6 theta, and that's what this allows us to do. So when we apply this, actually even before we do that, we can write this out as cos of 6 theta, and then plus I sine, and then 6 theta. So why this helps is when we now fully expand out this, we can now compare all the real parts of this expansion and make it equivalent to cos of 6 theta, and we can expand out all the imaginary parts and make it equal to I sine 6 theta, because all the real parts of one side of an expression, so this is going to be like one side of an expression, match all the real sides parts of the other side of the expression. So let's do that. So first of all, we have 1 from Pascal's triangle, we have c to the power of 6, and then we have is all to the power of 0. We add on to that 6 multiplied by c to the power of 5. So let's write that out. C to the power of 5. And then is, this time to the power of 1. We then add on to that 15 lots of c to the power of 4. And then multiplied by is all squared. We then add on to that 20 lots of... And I'm going to show you a trick to speed up this question later on in the question. Although it does seem kind of long now. C cubed, is cubed. And then we keep going on until we end up at using this last number here. That's a little trick on how you know when to stop. Another trick I'll show you. So c squared now, multiplied by is all to the power of 4, and then plus 6 lots of c to the power of 1, multiplied by is to the power of 5, and then multiplied by 1. And then when your cos value is now at the 0th power, and your other term is at its maximum power, that's when you know that's the stopping point. From there, we're going to think about, okay, we want to show cos of 6 theta is equal to all of this expression. That means we're only interested in the real parts of this whole expression here. Now, any odd power of I, we don't need to include that. So let's pick those out. For example, like I to the power of... Oh, sorry, that's is. Is to the power of 1. That gives you an imaginary part, so we don't need to include that. We're only interested in the real parts. Also, is to the power of 3. We don't need to include that because that gives you an imaginary part. Is to the power of 5. We don't need to include that because that gives you an imaginary part. All other 4 variables actually give you real parts. And let's go through how we determine those real parts. So first of all, this first one, is to the power of 0. That just gives you 1 because anything to the power of 0 is 1. Then we have 1 times cos to the power of 6. So that first term will become cos to the power of 6 theta. Moving on to the next term, which is this one here. The next real term, that is. Well, I squared is equal to minus 1. That's something that we know about real numbers and complex numbers. 15 multiplied by minus 1 is minus 15. So let's write that out. And then we have cos to the power of 4 theta multiplied by sine squared theta, which happens to be 1 minus cos squared theta. The reason I'm writing out like this is because I realize that everything in the answer is in terms of cos, so everything that's not in terms of cos, you want to make it in terms of cos. Moving on to this next term, well, I to the power of 4, let's focus on that first. That's essentially the same as I squared multiplied by I squared, which is minus 1 multiplied by minus 1, so that's positive 1. Positive 1 times 15 is positive 15, and then we have the cos squared coming in there, all multiplied by sine to the power of 4. Now, sine to the power of 4 is, well, let's write this out a little bit separate. Let's do it here. Sine to the power of 4 theta is like sine squared theta all squared, if that makes sense. The reason I put it in this format is because once it's in the form of sine squared theta, we can use the trig identity, where you make it 1 minus cos squared, and then all of that all squared. And then you add on to that this last term here. So I to the power of 6 now, let's be a little careful with this, is I to the power of 4, which we've introduced as positive 1, multiplied by I squared, which is minus 1. So that becomes a minus cos to the power of 6, theta, and then multiplied by, well, we've already dealt with I to the power of 6. Oh, sorry, I just realized this is a power of 0. It's my bad handwriting. Cos to the power of 0 is just 1. And then sine to the power of 6 is going to be, well, let's try this out here. Sine to the power of 6 theta is sine squared theta. We are going to have to change it into sine squared so that we can replace it with 1 minus cos squared, all cubed this time. So it will become 1 minus cos squared theta, all cubed. Now, when you do take the time to expand all this out and simplify all the like terms, collect like terms that is, you will get to this expression here. Because it does involve a significant amount of writing out, I think I'm going to leave it there for now. But yeah, hopefully this makes sense to you guys. Be sure to leave a like if the video did help and subscribe. I'd appreciate it a lot. Thanks for watching your video. I hope it helped. If you have any tutoring inquiries for A-Level Further Maths, be sure to hit my website up at www.excellineducation.co.uk.